Using integration by parts, u equals
X squared.
nothing. Those techniques only applied to an indefinite integral, or
You're right, the integral.
yeah, definite integral. So I think I gotta come in and rewrite, because I think this question is nothing more than this question. What's the limit as t increases without bound of the integral from 2 up to how much is it t? Of my x squared e to the negative x. I think that's the question. Now I think within the limit, I have every mathematical legal right to use the tools of calculus that I learned back in chapter, I think, 7. In other words, the integration techniques. So what's the appropriate choice of technique? You okay with that, Linda? All right. And I think integration by parts is the choice. So you and I let u be equal to x squared, and dv to be equal to e to the negative x. Only because I'm doing this, or setting this assignment, you guys, check this out. I get to reduce the order of that power expression through the differentiation process. And I think the relationship between du and dx is as such. But that means v is going to be, negative e to the negative x. And so I think I'm applying
What
that.
about the dx on top?
My apologies, I agree completely. I'm being sloppy. And so applying my integration by parts formula, I'm left with a limit. Okay, let's analyze this. Does that give me the u times v, which is a negative x squared, e to the negative x, minus the integral from 2 on up to t of my v du, which is a negative 2x, e to the negative x. And you guys, I'm happy. I may not be the happiest, but I'm happy in the sense that at least this integral, by using the integration by parts formula, has a smaller power for x than I started with. That kind of suggests that if I apply this approach again, then maybe I can whittle the power of x down from 1 to 0. So let's give it a shot. And applying integration by parts again. This time my new u is going to be equal to x, and my dv is going to be equal to my e to the negative x. Paying the consequence of my actions, du and dx are synonymous. And v is going to be the opposite of e to the negative x. So in applying my integration by parts formula again, I now have the limit, as t plays this game, of some stuff. By the way, you guys, sorry, I think this is another place where I kind of messed up with my notation.
Mm-hmm.
Don't you guys think I should be saying this? Watch the plus 2, I'll slide it over a little bit. I mean, eventually, don't I have to evaluate this one term as t ranges from here to here? I mean, I really should say that. But now I've got that one term, negative x squared e to the negative x, plus 2 times my new u times my new v, which will be a negative 2x e to the negative x. I'm going to evaluate that from 2 to t. Finishing up my integration by parts formula, I guess I better subtract off the integral involving v du. That means I'm subtracting off the integral involving e to the negative x, but there's a 2 up front. So I guess that gives me a positive 2 times the integral from here to here of v to the negative x. And I think that's an absolute piece of cake to anti-differentiate. I now have the limit as t increases that bound of some stuff, and here's my stuff. Is that a negative x squared minus 2x? Is that a minus 2 times e to the negative x, evaluated from here to here? So what's next? What is next? You have to do some subtraction. Actually employ that fundamental theorem of calculus that says, I take that a little back, not really a fundamental theorem, but just simply taking this antiderivative, evaluate the upper bound of integration, gives me this. Taking this antiderivative, evaluate the lower bound of integration, that would give me this. Look at their difference. And then take the limit as t plays that game. So far, so good, you guys. What's next?
Evaluate the limit.
But if I evaluate the limit, how do I evaluate this limit?
It goes to 0
How do
because,
you know that?
well, because it's got an infinity in the denominator.
But it's got one upstairs as well.
Yeah,
Did you you see?
Oh, you gotta do a low, oh.
So I think what I really have sitting in front of me is the
Screwed
limit
up.
as t increases without bound of the ratio of negative t squared minus 2t minus 2 over e to the positive t. Outside the limit, I've just got sitting over here, I have no idea what it is. Is it a 10 over e squared? Outside the limit. And if you guys want to show your work, that's fine. Or you can say, I know this grows so much more rapidly than a polynomial function, but let me show my steps. Using L'Hopital's rule. You guys, it might have been a while, so help me with this. Now the quotient rule says I differentiate downstairs or upstairs first. Neither. It doesn't apply. I'm not using the quotient rule. I'm using L'Hopital's rule, which says this kind of limit of an expression like this, where I get an infinity over infinity situation, is the same as the limit of the ratio of their derivatives, which is a piece of cake. Now, applying L'Hopital's rule again, because I can, I've got infinity over a situation, I think that leaves me with a limit as t plays this game. Is that a negative 2 over e to stuff, plus my number, this number. But now when I have actually valued this limit, using L'Hopital's rule, what do I get? Using L'Hopital's rule.
Nothing.
Nothing, it doesn't apply, it's not legal. I no longer have a 0 over 0 situation. I'm taking the limit as t increases the bound of the ratio of some constant to something that's increasing without bound downstairs. Clearly that's going to 0.
I have a quick question.
Yes,
Are we once we have once
So-
we do differentiation by parts here, and then we do another differentiation by parts up there?
Integration by parts.
Oh, I'm sorry, integration. Are we allowed to the two bounds?
Yes.
Are we allowed to put the terms together
I did up
to
to
do that? No?
absolutely.
I don't know that.
What's the difference?
Well,
I'm still
there
taking
isn't. I just wasn't.
each and every one of those pieces of values from 2 to t. So
Yeah.
I just combine them all together to reduce the amount of ink I need. So,
That's true. Okay, thank you.
come on, you guys attack me. Anybody else? Sean.
So how necessary is it for us to keep our notation through the whole way with our evaluations and our bounds and such? No, it's necessary, but.
This is a precise language. And part of what I'm doing through grading is coercing you. That's not probably word. You use the right notation. Just get off this.
So if we didn't use L'Hopital's rule,
What did you do?
I don't know. I mean, I got 10 e to the negative 2, so
Did you really?
I did.
In your mind, were you saying, be honest, in your mind were you saying, oh, come on, that thing grows so much more rapidly than this?
I was just like, that graph is probably gonna go to 0 because I want to get rid of that. So
That keyword probably,
there, but I did almost everything up until that. I didn't justify why I said it went to 0. So am I still gonna get most of the points?
I might attack you a point. I mean, the reason
So-
why I would normally attack you more points is just if the author already discussed, even Math 30, and I don't even remember if I discussing this with you, he even said, oh, these functions grow faster than these, everything's going to go to 0. I kind of was nervous, but I mean, I think we should verify it, but even he said it, so I can't nail you that hard on it. I'm kind of hoping you're at a point, anyway, instead you're saying exponential function grows rapidly, so much more rapidly than polynomials, it's always going to beat this one, which means the numerator is going to increase without bound so much more rapidly. Numerator, since the denominator does that, the whole fraction is going to go to 0.
So if I crossed that out and said it went to 0 but got the same answer,
I'd have a small tear. I wouldn't be crying, but I have a small tear.
okay.
Well, what did you say? You need more proof when you looked at my paper, because I did L'Hopital's rule and I got to that last point, said 1 over e to the t.
Well, I remember you saying something like this. Hey, since I know this goes to 0, don't I know this goes to 0?
Oh, no, because I did 2 over e to the t and I crossed it off and said that goes to 0, therefore by L'Hopital's rule, that whole term goes to 0.
If you run the e through, you can take out 2 over e to the t, right?
Yeah, I think I can live with that, but when I was looking at your work, you were saying, well, because this, isn't that true? I only saw this one.
Oh, okay.
So maybe I wasn't catching all that you're
Yeah,
saying.
I didn't phrase the question properly. Okay, cool.
Anybody else? Yikes.
What if we
Yes.
stated, we should use, L'Hopital's rule, but we didn't say we should use it twice? I just wrote it and then went straight to 0.
Oh, but that means you did use it twice, but you only showed you used it once.
Okay.
You see my point?
Yeah.
How many of you got this answer? Wow, that's fantastic. Glad to hear it. You know what, since we're just basically taking a break right now, can I take maybe 2 minutes